Hello. My talk is about generics. The title was made by Google's AI stuff, so it sounds fancier than it is. But it's a story of how I built a service with generics. First of all, I'm Teea Alarto. Great pronunciation by the organizers. Thank you. I'm a senior software engineer. I'm Finnish. I've been living in the UK for about 7 years now. I've been a gopher for about 7 years. I did some PHP along with Go, some Node, but Go has been growing, and now I'm only doing Go as of the late 5 years or so. I'm also one of the organizers in Women Who Go, the London section. And there it is. And I have ADHD, so I'm autistic and have ADHD, meaning I kind of need everything to be really systematically structured and in its place, but also I thrive in chaos, and when there's a huge mess, I really enjoy it. And this is the reason why this talk is structured, how it's going to be structured, you'll soon see. And I like hedgehogs. I just think they're neat. So let me set the stage. A lady hedgehog is out to build a new factory. She has built several types of factories in the past, but this time it's a bit different. This factory will only make pies. Usually factories have different kinds of parts that need to interact. Like if you have door factories, you build knobs and hinges, and then insert the hinges and the knobs into the doors. Or bicycle factory, you have wheels, frames, and gears. But this time it's just pies. Or maybe saying just pies is a bit wrong, as they could be fruit pies, berry pies, vegetable pies, even meat pies, pies of all sorts in their delicious glory. And to jump to a not so different story, I was tasked to build a new service. We had a mobile app for Android and iOS, and a legacy API built with JavaScript, TypeScript, something horrible. And the mobile apps talked to this legacy API. It had a lot of problems. First, the endpoints were a mess. They would take different kinds of payloads for the same endpoint. Sometimes they would be in JSON, sometimes in plain text, and you would get the same kind of stuff back. And the mobile apps needed to have a lot of complex business logic to determine what they're going to send to what endpoints and such. And duplicating the same business logic for Android and iOS, because these were native apps, was a lot of work and oftentimes led to all sorts of weird bugs where one platform was working okay, the other one wasn't, and it wasn't fun, but if you ever worked in a startup, this is what it looks like. So now I was tasked to build this new service into the middle. It would have strongly typed endpoints, a nice API structure, basically the kind of REST APIs pretty much everyone here probably hopefully builds if they happen to build those. And all the business logic was moved from the mobile apps to the service, because why build something 2 times when you can just build it 1 time? And so basically the service was dumbing down the mobile apps, and all the endpoints would have just simple CRUD functionality. So create, read, update, delete. You would create new things, read them, update them, maybe delete them, who knows? And there was no linking of data. There was no users and groups that you need to combine. There was just sending data, and that's updating and stuff. No fancy stuff, no doors and hinges. Now, I didn't want to write an API layer, service layer, database layer for over a dozen different data structures. I wanted to, because they would all be doing the same thing, saving data, sometimes sending it to legacy API, updating data. So being a lazy person, I wanted to do as little coding as possible. Little did I know. And I wanted to do things efficiently. So we still have the same kind of logic. We have the REST API layer that accepts the requests, the payloads, and has its own little logic. It checks for if the request is authenticated, if the user has access to the resource they're writing or reading from, and that the request payload is valid, the usual stuff. And then it sends the data to the service layer if everything was okay. And the service layer has all the logic. If we're creating new stuff, we check, does it already exist? If we're updating, does it exist? So we can update it. Same with reading, deleting. And then we transform the data to whatever format we need to send it to the legacy API to. And sometimes these would be several requests from just one request. And then return the appropriate response to the mobile client. And the database handles the database interaction, of course, creating, inserting, updating, deleting, selecting, and such. And we also send the data to the legacy API, which is kind of its own layer, but we're ignoring it in this talk. After all, it was in JavaScript. So some endpoints that we dealt with had users' personal information, like their name, date of birth, address. And then we'd use third-party service to scan their passport and verify that whatever they gave us was a passport set. So kind of validating that they are who they say they are. In the example here, we have 3 different data structures, 3 different endpoints where we want to send the data and get the data update and everything. And I didn't want to code like 3 different files for the REST layer, service layer, database layer, and so on to do things. I wanted something a bit more simple, a bit more generic. So back to our hedgehog lady. She tried all sorts of solutions to design her factory for making the pies that would require the least amount of work. She didn't want to make a factory for strawberry pies and one for blueberry pies, one for lamb pies, and so on. She wanted to have just one factory, because after all, it was the filling that changed. So she built one pie assembly line and then removed all the moving parts and duplicated these parts that were changing for fruits and meats. And eventually this was something she had seen before, but it ended up giving more grief than joy. And she looked into pie generics, a thing she had slightly heard in the past, but only for smaller parts, not for big things, big factories, only for little moving nozzles. And bravely she ventured forth, looking for information on how this could be done. Of course, research was fun, but we're still lazy and don't want to write a lot of code, especially repetitive code. But this was no easy feat, not to her at least. She couldn't find anyone who had done this kind of thing before. There were no videos on the HedgeTube. There was no way to look at pie generics on a bigger scale. Just you would have like these little nozzles, lots of conference talks on how generics work, but they never went into depth, and that's what we needed. So back to code. Much like the hedgehog, I tried solving the problem with templates. After all, Go has templates, I think pretty much from the start. So I wrote one of these endpoints, then made it a template, used variables to change from address, name, or date of birth here and return the same kind of stuff. And the resulting template looked horrible. On VS Code, if you looked at it, it wouldn't do syntax highlighting because it was just basically plain text. At least not on mine. Maybe there's some kind of add-on or whatever. And when you converted the template file back to Go, I made a little tool that would take parameters like address and then insert it into different parts, output a Go file. It often had some bugs, but editing the template file was really difficult because it wasn't Go, it was something weird. And I had seen people do this in the past, like making these kind of Java factories with Go, where you give something and it handles all the database interaction, for example. But for me, this just started feeling more difficult and harder to maintain. Like when I finally got it ready, I needed to change something. The template was horrible to start making the changes, so I was just like, this isn't a nice way to do things. But while I was doing that, inserting the address into the variable in the template, it started looking a bit familiar to me from another point. I had only used generics on a surface level, and realizing the similarity between what the template was doing and what the Go generics were, it opened up a new rabbit hole or a hedgehog burrow that I just needed to tumble into. So let's do a really quick generics 101. Here we have slices.Contains from the core library, and it calls for another method index. And this is, it has two variables it takes, S and V. And it really looked intimidating when I was looking at it. I hadn't actually dove into generics at this level before. And I was like, what is going on here? I have no idea. I'm just a simple gopher from before 1.18. And here we have a method using slices.Contains. If none of you have used it, it's pretty simple. First, we have the string slice that has foobar and bus strings. Then we call slices.Contains. Give it a string slice as or string array as the type, and then look for bus in string slice, returns true. Same with integers. The only thing that changes is the string and the int, so it knows what type are we dealing with. So this kind of looks simple, but back when you look at these, like the contains, what's the tilde before square brackets and E? What is the comparable? Here we have S and E, but we only define one, either slice of strings or slice of integers. But this has two things. The more I looked at it, the more it felt like I have no idea what I'm doing. And the meme with the dog in a lab coat, I very much felt like that. And I looked at the talks that have been done in the past several years in conferences, but they just didn't open the world to me in a way that how can I make this work in my service? So I still started building it, Googling, looking at Reddit, Stack Overflow, whatever I could get my hands into. I even used ChatGPT. Wasn't very fruitful. It didn't understand what I was doing, so that made two of us. But there was a lot of trial and error and getting the different blocks to work together. So I solved this by defining the type when creating the API endpoints, and then letting that information flow through the service layer and database layer. And here it gets scary because I need to do some coding. So first, what I did was I pretty much copied stuff from, I can't remember, go.dev or somewhere, and I defined this data type, which defines that this is a kind of generic variable that has to be of type address, date of birth, or name. So you can't put anything else as a data type. And then I created the root. So I created these set item roots helper method that takes one of the models, gives it the router, and just a string on what it's about. So here we have fuego.post. Fuego is a library that outputs, for example, OpenAPI 3, and creates a slash, whatever the string is, and calls for create. And now it has this T here. And T refers to the model's data type that I just showed you. And then we have the actual create method, which also has this T model data type. And we get the body. Fuego has this helper function. And when we look at the request variable, it shows us T. So, hey, we're getting somewhere. So let's run this and make a simple request to post an address. Now, of course, we don't see anything here, but we see that it has the street, city, postcode, and country, just as we defined here. So, hey, we're getting somewhere. We're actually having a generic address, whatever that is, and we have some values in it. That's great. So since we're creating a new address, we need to create an ID for it. So what I did was create a UID and set it to the request. But this gives an error because ID is undefined. T has no field or method ID. And if we look back to data type, this is an interface. I can't just be putting the ID string here. I mean, this is a new thing that I can list these. So what am I to do? So we go to the second iteration. Now we define a method on the interface or a stub of a method that returns base. Now, if we look at the variable address or the struct address, it has base that has created that, updated that ID and transaction ID. So, okay, we get the base, we put data in it, we save the base. I mean, that solves the problem, right? And here we have the model. I wrote the get base that returns base or pointer to it. And I already wrote the set base where you set the base and return a pointer to the whole model. And again, we put the ID, get the transaction ID from the path. We create the base model. And we can log stuff here to see what things look like. And yeah, we have this is logging the base. We have the pointer to the ID, pointer to the transaction ID. Everything's looking okay. So let's go back to the data type and uncomment this. And now there's another error. We have no access to this variable because we don't know what T stands for. We know it's going to be one of these three, but GoLab doesn't know. It doesn't know what we're meaning because it's even dumber than I am, which is an accomplishment. So yeah, we go to the third iteration. We again struggle with Git. Yes. So how we solve this is we create another type that takes the data type as a generic type, and now we have access to the T. We still have the same get base and set base methods, so we need to write them. But we already wrote them in address, so we don't have to change that. And again, we do the same thing. Create the ID. We have the base defined here already? No. And we call setBase. And then we call this. Now, this has some wonky stuff, because we're dealing with the T type, that is an address, but we want it to be an item type with the underlying data type. So to solve that, we need to create an interface, put the request, which here is of type T, to that interface, and then we can cast it to be an item, and it becomes item of that type. We have access to the T since we're calling create with a T. We also needed to do some other stuff, other wonky stuff, where we create a new struct and give it the value and the service pointer to the service layer. And we have a constructor where we create the new value. Do I have everything here? Yes. So let's run this thing again and see what we can get. So now we have the base filled correctly. We have created that. We have pointers to ID and transaction. And we have the actual body with the street name and everything. This looks nice. We're making huge progress. So now what we need to do is we need to save it to the database. So what we do is, first this is on the API layer, we call the service layer, and on the service layer we have defined a similar kind of structure. We have the op struct, we have the same constructor, and we call the same create or eventually get methods, and they take the type information. And on the create method we have calling database, new ops create, and the database layer is pretty much the same, except it uses GORM and saves the item and returns nil. So back to the API ops. Now we're creating the stuff and we're returning the result on what happens. So let's run, and this time on our API tester we should actually see something, and yes, there it is. The model, everything is updated, and since it saved it to the database, if we do a get, we actually see the data, now it's in the database. And the fun thing is, we were only checking with address, but since we are defining the roots for name and date of birth, if I send a name, it functions out of the box, and same with getting the name, because that's the whole idea. We just swap the model, everything else works, we're saving stuff into different tables. And was that just a moment, yes. Great. So back to our hedgehog lady. Yes. So after a lot of trial and error and Googling for so many error messages that just didn't make any sense to me or our hedgehog, she managed to build her generics factory in somewhat working order. You still needed to make some items such as nozzles or get item and set item for each type of filling, but overall the factory started to look functional, and adding new types was really simple. You just added a new function call for a new type, and voila, you could post and get, update, and whatever you wanted to do. So it worked really well. And now the Pi factory was open for visitors, and the mobile Pi developers, who the service was for, came in, or who the factory was for, came in and had a look, and problems. While the pies were tasty and everything that they had wanted, they didn't quite like how they were structured, how they looked. The mobile pie people wanted the look and feel of the pies to be a bit different. For packaging, they said there has to be forest branding, and they wanted to sort how the feeling was actually delivered. So our hedgehog developer needed to make changes for the incoming pie orders as well as outgoing pie deliveries. At first, this looked like the end of her generic pie factory, because it was working, it was difficult, it was there, please don't change it. But change was forced upon her. But where the generics was the problem, more generics was the solution. So the mobile end, this is what we were seeing before, the payloads, and they wanted to structure it a bit differently. Now, me being a backend developer, why do they want to do this? I don't know. But I know that a lot of front-end developers want there to be different kinds of structuring for the same data. So they wanted the responses to look this. There's the data object that contains the actual data. Everything else is there on the head. And when they sent data, they wanted to have this data structure that contained the data. Now, why? I don't do Android or iOS, so I don't know. But I still wanted to have in the root description for it to use the actual model. So when I output the OpenAPI 3 spec that comes out of the box with Fuego, and we were using Gin with some add-ons earlier, so I needed to define the request and response types as separate. I couldn't just say that it's an address type and it returns an address type, because that would be lying. But I was still wanting to use the base type internally in the service for when I want to send stuff to the legacy API, when I want to save stuff to the database, and just in general when I want to do anything with the data. So changing the models to accommodate the needs of the mobile pie people caused a bit of a panic. Was this the end of the road for the generic shenanigans, or did I dig myself deeper into the hedgehog burrow, and now I had to rewrite a whole lot of code that I just got working to make the thing work? And I did a lot more research, but in the end it proved that my approach to how building this service with generics was pretty much the correct one. I only needed to adjust the API layer, because that was the one that was dealing with either the request or response, and everything else could just remain the same throughout the service and not require any touching. So, yay, more code. We check the fourth iteration, and have the same issues. So, to accommodate for the mobile pie developers, we created two new types: request type, which is address request, name request, or date of birth request, and it has a function called toModel, which returns the original T. And for this, we have to define, of course, the T, just as we had to do with the item, so Go understands what the T is. And we created the response type, which has address response, name response, and date of birth response. And the requests looked pretty much what you'd accept. You have the data, as you saw from the slide before. And the response has now the base on its own, so it goes to the root item. And then data, which contains the type-specific stuff. And it has two response method that returns the response type. Here's the address, and I separated what was originally the contents of this struct to a different one. We have the original get base and set base, but we now have the to response. And address request that returns the data. And we have the to model and the to response. I'm going pretty fast, so sorry if it's. And for when we have this helper function for creating the routes, we give it the original data type, but now we give it the request models data type, where we inject the original, and the response model T. And these go to T, rec, and res. So when we call, again, the constructor, we give it the T, res, and rec, and res as types that it needs to understand. So here, repetition, and here again, we put the values there. Now when we call create, we have all these different kinds of types. And now when we get the body, we get the request type. Request has the to model, so when we call request to model, we get the original type or the base type. Again, do the wonky casting to get it into an item, and set the base data, and call the service layer for create. Now notice, I don't need to define the request or response models here, because this remains the same. Everything else but the API layer remained the same. And when I get the response from the API layer, which is again pointer to T, we cast it to a response item, and then we can call that to response. So we get the actual response model. So let's run and see if this actually works. It worked last night, so who knows. And for this, we have new endpoints. So we now just send this data structure, and we do a create, and we get the created, updated, and then the data is in its own little cute little object. And same when we do a get, we get the same kind of stuff. And again, when we do the same kind of stuff for name, it works out of the box. I don't have the date of birth here, but you have to trust me that it works too. And I'm a very trustworthy person. Yes. So back to hedgehog ladies. So after all that kerfuffle, both I and the hedgehog protagonists had solved the problem successfully. At least I think so. And the mobile devs were happy, and they are the people that matter, because they do fancy stuff. And there was a lot of changes we had to do to the service, of course. It wasn't just this. We had some models that, some types that needed to, for example, retrieve tokens from third-party services, but adding it to the point where we do the response model was fairly simple. If it is of this type model, they were more like exceptions to the underlying logic. And other small iterations that we had to do, either to all the models throughout, or doing a little changing of small things, it proved to be really simple. At least there weren't like 15 files on each layer I needed to edit when I needed to change ID to, for instead of having the small d to having a capital D or something like this. It was pretty simple. And as final thoughts, what did I learn from my adventures in generics? For anyone looking at the code that I showed and who isn't familiar with generics, it might look a bit scary at first. You're like, what are these T, rec, res? Why are there things in brackets? What is this? But generics have been part of Go since 1.18, and actually 2 days ago it turned 5 years old. So it's a pretty solid part of the language. It's been there for the third of the time. So it's not like some shiny new feature that I just discovered and wanted to use because, hey, shiny. And building code in a way where the flow stays the same throughout different layers made it much more easier for devs that weren't familiar with generics, weren't familiar with this service, and just had to jump in and do changes. Made it easier for them to understand because the API layer, service layer, database layer all had the same kind of constructor, same kind of logic that was happening there. Apart from the API layer, which had a few extra nodes, the generics remained the same, and it made it easier for any developer to understand. And adding things such as new models, it was just adding the lines, and we handled the tokens and other changing things by adding a metadata and having to response handle it. And having generics could use some love from the code team. Having to write the set base, get base, to model, to response methods for every single different type was a bit annoying. I didn't want to write the same kind of code, and that was the whole purpose of using generics. So while there's no inheritance in Go, I kind of wish there was something that wouldn't be under the title inheritance, but would still be inheritance, like building the base struct that every other struct derives from. And I really would like to see generics go towards this in the end. So here's a QR code, takes you to Linktree. It has links to my socials, this code in GitHub that you saw, because I went through it pretty fast. And if you're looking at getting into understanding generics on a larger scale, I think that's a really good, I would have wanted someone to have done this 1.5 years ago when I was stumbling through this stuff and getting really frustrated to the point of tears. Yep, that's it. Thank you.
Thank you. Are there any questions? Yep.
So first of all, thanks for your talk. Just a small question. When you added generics to your application, did you also notice some performance implication or any difference around that?
No, because this was a REST API service. The performance is not an issue. You're just saving stuff to database, reading from database. If it adds a few nanoseconds, even milliseconds somewhere, it's still just simple REST. If you want performance, then it's a different matter. But on this whole system architecture that we were dealing with, it didn't matter that something took a few milliseconds longer. And overall, this service improved the performance because it saved it in its local database, as well as sending to the legacy API. So when you did a simple get, it would get it from the local database instead of making a network call to the legacy service, which was actually using something called ArangoDB, which is a database. And if you haven't used it, stay away from it.
Okay, another question? Don't be shy. Oh, yeah.
So, did the introduction of generics in your code somehow affected the compile time duration of your application?
Not that I noticed. If it did, it went from, let's say, 3 seconds to 3.1 seconds or something like this, so I wouldn't notice. It's not like it was compiling for tens of seconds or longer, so any difference was unnoticeable.
Anyone? Okay, I guess that's it.
Yeah. Thank you for listening.